Welcome to this tutorial on the real number system. In this video, we'll break down the components of the real number system, explain their differences, and show you how they all fit together. What is real number system? Real number system are numbers that can be used to measure a continuous quantity such as distance, duration, or temperature. It can also be defined as the union of both rational and irrational numbers, and they can be positive or negative numbers. And they are denoted by the symbol R. Let's start with natural numbers, also called as counting numbers. These are numbers that we use to count everyday objects, beginning with 1, 2, 3, 4, and so on. They are symbolized by the letter N. Next, we have whole numbers. These are numbers that include all natural numbers beginning with 0, 1, 2, 3, and so on. Whole numbers are non-negative and they do not include fractions and decimals. Let's introduce integers. Integers are a set of whole numbers and their negatives. This means they both include positive and negative numbers, like -3, -2, -1, 0, 1, 2, 3, and so on. We use the symbol Z to represent this set.
I'm Rolando Paspas Jr., a Bachelor of Science in Accountancy 1 BB student. I am your tutor for the day, and my topic would be around the differences between rational and irrational numbers. So what are irrational numbers? Irrational numbers are those numbers that can be explained, just like integers, whole numbers, natural and counting numbers, terminating decimals, and also those non-terminating decimals that has a repeating numbers, and those fractions that our denominator is not equal to 0. On the other side, irrational numbers are those numbers that cannot be explained, or those numbers that cannot be represented in fraction, just like the value of pi, those imaginary numbers, the square root of 2 and 3, and those non-terminating decimals that are non-repeating numbers.
Hello everyone, this is L'Oreal Cantilang, and today I am going to discuss about the numeration system. But before we begin, let us define first what is numeration system. So what is numeration system? Numeration systems are developed for representing quantities and are used in order to perform any of the four simple mathematical operations. Throughout history, a variety of numeration system has been developed to represent numbers. These were the tally system, Egyptian system, Roman numerals, Hindu-Arabic, Mayan, and Babylonian numeration system. However, in this lesson, I am only going to discuss the two of them, which are the tally numeration system and the Egyptian numeration system. So first is the tally numeration system. What is tally numeration system? Tally numeration system is probably the simplest of all numeration systems ever used. It makes use of single strokes to represent object being counted. A tally mark is represented with the symbol L. They are represented as a set of 5 lines in which there are 4 vertical lines. One vertical line is made for each of the first 4 numbers, and the 5th number is represented by a diagonal line across the previous 4 numbers. Moreover, if you would write 5 and more, you just have to repeat the process. Next is the Egyptian numeration system. Egyptian numeration system is this numeration system evolved around 3400 BCE. It uses special symbols to represent numbers that are powers of 10. The Egyptians used a written numeration that was changed into hieroglyphic writing, which enabled them to note whole numbers to 1 million. The system had a decimal base and allowed for the additive principle. In this notation, there was a special sign for every power of 10. For 1, a vertical line. For 10, a sign with the shape of an upside-down U. For 100, a spiral rope. For 1,000, a lotus blossom. For 10,000, a raised finger slightly bent. For 100,000, a tadpole. And for 1,000,000, an astonished man with upraised arms. So I guess that's all for today. See you and bye-bye!
Good day everyone, my name is Shanjard Amaka and I am a second year best IT student and I am your tutor for today. Our topic for today is all about Babylonian and Mayan numerical system. So what is a Babylonian number system? It is one of the earliest known and was developed by the Sumerians around 2000 BC. It is a base 60 system which is quite different from the base 10 system that we use today. So below are some examples of the Babylonian number system. So what are the key features that we need to know of the Babylonian system? First, it uses the base 60, which is different from our modern system that uses the 10 digits 0 to 9. Second is the cuneiform script. The numbers were written using cuneiform symbols on the clay tablets. And lastly, the positional system. Like the modern system, the value of a symbol depends on its position. So how to write numbers in a Babylonian system? The Babylonians uses two symbols, a vertical wedge which is let's just say a small stick to represent 1 and a corner wedge which is the big stick to represent 10. These symbols were combined to write numbers and their value was determined based on their position. Since they had no zero, they left spaces to indicate a gap. So example, write the number 34 in the Babylonian system. So 34, the 3 is a 10, so we need to write 3 big sticks and 4 is a 1, so we need to write 4 small sticks. So for the Mayan number system, the Mayan numerical system was developed by the Mayans of Mesoamerica. It uses a base 20 system and it is best known for its advanced calendar system. So below are the examples for the Mayan number system. So what are the key features of the Mayan system? It uses the base 20. Instead of using 10 as a base, the Mayan counted in groups of 20. And the symbols, the Mayan used 3 primary symbols. A dot for 1, a horizontal bar for 5, and a shell symbol for 0, which was one of the earliest uses of concept of 0. And lastly is the vertical positional system. Mayan numbers were written vertically with the lowest value at the bottom. So how to write numbers in the Mayan system? Mayan numbers were written by stacking dots and bars in vertical layers. Each position was a power of 20. So, for example, write the number 13 in the Mayan system. So, 13, it uses 2 bars and a 3 dots, so this is how you write them. So, that's all from me. Thank you.
Hi, my name is Johanna Alvarez, a second-year medical technology student. Welcome to today's discussion on the numeration system. Throughout history, humans have developed different ways to represent numbers. Today, we'll be focusing on two of the most important systems, Roman numerals and Hindu-Arabic numerals. First, Roman numerals. This numeral system originated in ancient Rome and was used throughout the Roman Empire. It is based on the symbols here in the pictures representing the numbers 1, 5, 10, 50, 100, 500, and 1000 respectively. Roman numerals are additive, but sometimes subtractive. For instance, here we have the symbol of 6. It has 5 plus 1, while for the symbol of 4, it has 1 and is subtracted by 5. Despite its widespread use in ancient times, it had limitations, especially for larger numbers and complex arithmetic. since they don't have a symbol for zero and they lack the place value concept we're familiar with. The Hindu-Arabic numeral system, which originated in India and was later transmitted to the Western world by Arab scholars, revolutionized mathematics. It's a positional system, meaning the position of each digit determines its value. This allows for far more efficient representation of numbers, whether large or small. For example, here we have 507 uses 3 digits in this system, whereas Roman numerals would require D, V, and 2 I's to represent the same value. Zero was a crucial innovation of the Hindu-Arabic system. It serves as a placeholder in the positional system, helping differentiate numbers like 10, 100, and 1000. Zero also made it possible to perform more advanced mathematical operations like addition, subtraction, and multiplication with ease. Without zero, performing calculations would have remained much more difficult. So, to summarize, Roman numerals served their purpose in the ancient world, but the Hindu-Arabic numeral system, with its inclusion of zero and the place value concept, enabled more advanced mathematics and became essential for modern development.
Welcome! In this quick tutorial, we'll show you how to convert a decimal number to binary. Step 1. What is the decimal system? The decimal system is our everyday number system based on 10 digits, 0 to 9. It's called base 10 because each digit's position is a power of 10. Step 2. What is the binary system? Binary or base 2 uses only 2 digits, 0 and 1. Computers use the system to process data. Step 3. Dividing the decimal number by 2. To convert a decimal number to binary, divide it by 2 repeatedly, keeping track of the remainders. Step 4. Write down the remainders. Divide 13 by 2. The quotient is 6, remainder 1. Continue dividing the quotient until you reach 0. Recording the remainders. 13 divided by 2 equals 6, remainder 1. 6 divided by 2 equals 3, remainder 0. 3 divided by 2 equals 1, remainder 1. And 1 divided by 2 equals 0, remainder 1. Step 5. Reverse the remainders for the binary result. So, 13 in decimal equals 1101 into binary. Step 6. A quick example. Let's do another quick example. 19 in decimal becomes 10011 in binary. And that's how you convert decimal to binary. Thanks for watching. And don't forget to try it for yourself.
Hello everyone, I'm Lady Wen Bancure and we're going to talk about whole numbers, place values, and how to round off whole numbers. Let's dive in. Let's start with the basics. Whole numbers. So, what exactly are whole numbers? Whole numbers are the set of numbers that start from 0 and go all the way to infinity. These numbers don't include any fractions or decimals. They are simply 0, 1, 2, 3, 4, and so on. Pretty simple, right? Here are some examples of whole numbers. 0, 7, 123, and 5,000. Remember, they do not have any decimal points or negative values. Now that we know what whole numbers are, let's move on to place values. Place value helps us understand the value of each digit in a number based on its position. Let's break down the different place values in a number. Every digit in a number has a specific place value, which determines its worth. Let's go through them one by one. Starting from the right, The first digit represents the ones place. Next, we have the tens place, hundreds place, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, trillions, 10 trillions, 100 trillions, and so on. For example, if we take the number 4,783, each digit has a place value. The 4 is in the thousands place, meaning its value is 4,000. The 7 is in the hundreds place, so its value is 700. The 8 is in the tens place, meaning its value is 80. And finally, the 3 is in the ones place, which stays as 3. So, the place value of a digit tells us how much that digit is worth depending on where it's located in the number. The further to the left a digit is, the larger its value. Remember, the place values keep increasing as you move left. Now, let's move on to rounding off whole numbers. Rounding helps us approximate a number to make it easier to work with, especially when doing quick calculations. The rules are simple. Step 1. Look at the digit to the right of the place value you're rounding to. Let's say we want to round 4,783 to the nearest hundred. First, look at the digit to the right of the hundreds place, which is the 8, the number 8. Step 2, if that digit is 5 or higher, round the place value digit up or add +1. If it's 4 or lower, keep the place value digit the same. In this case, the digit is 8, which is higher than 5. So, we round the 7 up to an 8. Step 3. After rounding, replace all digits to the right of the place value with 0. 4,783 rounded to the nearest hundred becomes 4,800. Let's try another example. This time, let's round off 3,246 to the nearest thousand. Step 1. Look at the hundreds digit, which is 2. Since 2 is less than 5, we don't round up the thousands place. Instead, we keep the 3 the same. Step 2. Replace all the digits to the right of the thousands place with zeros. So, 3,246 rounded to the nearest thousand becomes 3,000. And that's it. Let's quickly recap. Whole numbers are simply numbers like 0, 1, 2, 3, and so on, without fractions or decimals. Place value tells us the value of a digit based on its position in a number. Rounding off numbers makes them easier to work with by either rounding up or keeping the digit the same based on the rules.
Today, everyone, I'm Leonardo as a Authentical, and I'll be teaching you how to transform the standard form to its word form expanded. So first, we have the standard form. So standard form is the usual way of how we write numbers. It's indicated as numbers. That's all. So to write it in the word form, you have to pay attention to its place value. So first, we have 283. So to write it in the word form, you have to remember the place value of each digits. So usually the ones, tens, 10,000s, tens, 10 millions is not written in the word form. Since if you write 83 and two digits that is joined with by a dash sign, it can be understood as a two-digit number. So here, since 2 is in the hundreds place, you have to write 200. Then 83 can be understood as a two-digit number, which will be written after the 200. Next will be the thousands place value. We have 184. So same as we did previously. 1 is in the hundred place, so 100. Then followed by the 84. And since it's in the thousand place value, we have to write thousands and separate it using the comma. Another example will be 283 and 200. So we already did the word form of the num the word form of the number before the decimal point. So in here, if you write it in the decimal point, so same as usual in 283. So as for the decimal point, in the word form, you have to use and to separate the whole number and the decimal numbers. So here we write and the 200 since 2 is in the hundreds place value. So to write it in the expanded form, we have to write the each number in its according to its place value. So since 1 is in the 100,000 place, so we have to write 100,000. 8 is in the 10,000 place value, so 10,000. 4 is in the thousand, and so on. So if I add it all, it will result to 184,000. Alright, 283. So write the number, to write a number with the decimal place value unit in the expanded form, we have to use a fraction. So since 2 is in the hundreds place value, we have to write 2 divided by 100. So it will result as 0.2 if we calculate it. So if we add it all, it will result to 283 and 200. So that's all for my presentation.
So comparing numbers is all about determining whether a number is lesser than or more or greater than a number, or if it is equal to another number. What we have here is a few examples where it says 10 is lesser than 20, which is a greater number. We also have 30 is greater than 15, and 5 is equal to 5. Here we have a few more numbers that we're gonna try to compare. When comparing decimals, we start from the whole numbers part, and since 5 is equal, we move on to the tens place. Since 6 is greater than 0, we can already conclude that 5.602 is greater than the other number. And here we have 16.102 and 17.243. Since 16 is less than 17, then this means that 16.102 is less than 17.243. Here we have 1 half and 5 over 10 being compared. Since the, t- the two numbers is equal to 0 0.5, we can say that 1 half is equal to 5 over 10. So now we're gonna move on to the order of operations with PEMDAS. So PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. This is a rule in solving complex math problems where you start with the numbers on a parenthesis and then take care of the exponents if there exists one. Then we do the multiplication first and division if there is one, addition next, and subtraction. For me to properly demonstrate how PEMDAS is done, let's try solving this problem. So we have 7 plus 6 times 5 squared plus 3. Since we have an exponent here inside the parentheses, let's try solving this one first. So since 5 squared is equal to 25, this should come out to 6 times 25. In PEMDAS, since multiplication comes first, then the addition, it should come out to 150. Now we have 7 plus 150 plus 3. Let's finish taking care of what's left in the parentheses. 150 plus 3. We have 7 plus 153. And finally, the sum of the two numbers is 160. So now let's try solving a different problem. In PEMDAS, we do the parentheses first. So 1 over 2 is equal to 0 0.5. Next is the exponents, and 2 squared is 4. Next in the equation is the multiplications. So 20 times 2 comes out to 40. And then the product of these three numbers is 19.6. And lastly, we do the subtraction. So 40 minus 19.6 comes out to 20.4. And here we have the final answer. So before I go, let's recap what the order of operations are. So the numbers inside the parentheses comes first, then the exponents, then we do the multiplication, then division. Next up, we do the addition and subtraction. That's all.
Good day, everyone. I hope you're all doing well. My name is Herculano Vong III S. Alibo, and I'm currently a second year BSIT student. I am thrilled to be your tutor for today's session, and our topic is a fundamental concept in mathematics that you'll use throughout your academic career and daily life, which is fractions. Today, we are diving deep into the world of fractions, and specifically we'll be focusing in two key aspects: the definition of fractions and the proper fractions. These concepts are crucial for understanding the more advanced mathematical ideas, so make sure we build a solid foundation of it. So, go. What is a fraction? A fraction is a way to represent a part of a whole. So it's a mathematical expression that describes a ratio between two numbers. So every fraction consists of two essential parts, which is a numerator. So this is the number above the line in a fraction, and it represents the number of parts we're considering or focusing on. Second is the denominator. So this is the number below the line in a fraction. So it represents the total number of equal parts that make up the whole. So we write fractions with the numerator above and above a horizontal or the slanted line, and the denominator is below it. So example of this is this. It is 1/2 or 1/2. Here, the number 1 is the numerator and the 2 is the denominator. Next is proper fractions. So what is a proper fraction? A proper fraction is a fraction where the numerator is less than the denominator. So in simpler terms, it represents a number that is less than 1. So uh, this is a visual representation of a circular pie chart. Uh, as a proper fraction will always represent less than a full circle. This is a 2/3 and a 2/4. So so the number is always smaller than the denominator. So when divided, the result is always less than 1, and they represent a part of a whole, not the whole or more than the whole. So next will be how to identify a proper fraction. So to determine if a fraction is proper, you can just follow these steps. So you can just look at the number, at the top number, and the denominator of the bottom number. And next is compare their values. And the third one is if the numerator is smaller than the denominator, it's a proper fraction. So an easy way to remember this is to think of proper fractions as proper because they're less than one whole. Remember, for a fraction to be proper, the numerator must always be less than the denominator, as this ensures that the function represents a part of the whole, not the whole itself or more than the whole. So that concludes our detailed tutorial on fractions, focusing on their definition and the proper fractions. I hope this information has been clear and helpful. So uh, it seems complicated at first, but with practice, working with fractions will become your second nature. Keep practicing and don't hesitate to ask for help when you need it. Thank you for all your attention and good luck with your studies. And remember, in the world of math, every problem is just a fraction of your potential.
Good day, I am Danny, and today I will be discussing about the improper functions and fixed numbers. So, first, let's talk about the fractions. So, what is improper fractions? So, improper fractions are fractions that the numerator has greater value than the denominator. So, let's have the first example. We have 5/2. So to convert this into a mixed number, you need to divide 3. So 5 divided by 2. The dividend should be the whole number. And the remaining should be the numerator. And just copy the denominator of the numerator. So the answer to convert the So next example is say an example that we need to divide the two numbers. Then they should look like themselves. The chicken and the remaining chicken. And just copy the middle name. That's the example here too. So now let's head on to mixed numbers. So what are mixed numbers? Mixed numbers are a combination of a whole number and a double fraction. So let's have an example. First example from 2 and 1 So to convert this into a double fraction, we need to multiply the whole number and the denominator and then add the numerator. So 3 times 2 is 6, that's 1 is 7. So your numerator in the double fraction should be 7. Then this will be the 3. Actually, your expansion. So for the next example, we have 4 and 7. So say that first example, you need to multiply and add. So 7 times 4 is 28 plus 5 is 23. So just copy the denominator 7. That is your proper.